3.5, the chain rule. If f and g are differentiable at a, then Goff is also differentiable at a. And Goff prime of a is equal to g prime of f of a times f prime of a. All right, for f of x equals sine of x and g of x equals 3x. To find Goff prime, easiest way to try to do these, g is your first number, so I'm going to look at the g. What's the derivative of g? 3. So I'm going to have 3 times, now put this in for x. What do you notice? There's no x, so there's nothing to put in for this one. Times by whatever f prime is. What's the derivative of sine? Cosine. So I have cosine of x. Your answer is 3 cosine of x. If this was an x squared, the derivative of g is 6x. So you have 6 times, I put this in for x, sine of x. Then I take the derivative, cosine, yes, and then cosine of x. Most of the problems that you see aren't going to give you an f of x and a g of x and tell you to find Goff prime of x. You're going to have something where it just says find the derivative of the square root of 1 plus x to the 4th. These are the types of problems I've been avoiding for a while now. When you have this problem, you look. What's being put inside of another function? This 1 plus x to the 4th is inside of the square root. So I'm going to call the 1 plus x to the 4th your f. I'm going to call the square root of that g. Now find the derivative. What's the Goff prime of x? What we're doing is called the chain rule. So you break it into 2 pieces. I'm going to find the derivative of f. So f prime is going to be 4x cubed. For g prime, now square root really means to the half. So when I take the derivative, it's 1/2 x to the negative 1/2, which when I write it properly, 1 over 2 square root of x. Now to combine these together now.
So you can't do like that?
I don't like leaving that. There's too many numbers going on. It looks a little bit neater, and you'll see what happens here. To find the derivative, take the g, 1 over 2 square root of, but instead of writing x, I write this, 1 plus x to the 4th, times the derivative of this one, 4x cubed. I'm going to go and simplify. 4 over 2 is 2x cubed over square root 1 plus x to the 4th. And that's your answer. All right, f of x, g of x. You said that f, 5x cubed minus x to the 4th. G is x to the 7th. When you take the derivative, you get 15x squared minus 4x cubed. when I take the derivative of this one. You get 7x to the 6. So when I have Goff prime of x, you have g, 7, but instead of writing x, you put the whole original f. X, or 5x cubed minus x to the 4th times by 6, or to the 6th, times by the derivative of f, 15x squared minus 4x cubed. I am not going to super duper quadruple FOIL. I leave it like this and we're finished. Alright, different words. That's the only thing you see here. You're finding the slope of the line tangent. Well, find the slope of the tangent line, that's just the derivative. You have y equals sine to the 5th of x. One thing you need to remember, this right here means that right there. And when we're talking about this point, when we're talking about trig functions, they're either in degrees or radians. Which one is that? Deradians? Radians. How do you know it's radians? What's the dead giveaway? The pi. So what we're going to do is find the derivative of that. All right, if I call f is going to be, and g is going to be, what's f? Sine of x, g is going to be x to the 5th. Finding the derivative. The derivative of sine? Cosine. Derivative of g? 5x to the 4th. Piece it together. You have 5. Instead of writing x, I write sine of x to the 4th times by cosine of x. Here's the one new part. What we're going to do is solve it for x is equal to pi over 3. So just plug it in. 5 times the sine of pi over 3 to the 4th times by the cosine of pi over 3. All right, calculator is in radians. So I'm taking the sine of pi over 3.
Yeah, 1.4. How many decimal points do you want?
3 decimal places.
1.406. Yeah, that's.
Oh, come on, go back. All right. The 5 doesn't go on the inside because it's 5 times that to the 4th. Well, that set of parentheses goes towards that. That's going for all of sine. So we get as an answer 1.406, and I'm just going to go 2.5 because what's another couple decimal places?
I thought all later, and I'm still recording.
Is this starting to become a little bit easier?
No, I got all later. I think so. I understand.
I have k of x equals e to the cx. Wall of f, wall of g. The main function that's affecting everything is the e. The piece that's getting put into the main function, it's the x.
Right, above for the E.
That would be your x.
I help with it.
That's what I thought too.
The first part is CA.
Cx is this little piece. E to the x is the main function.
How is that the X affecting?
It's the main function is e to the.
So why is it
In this one here, what's affecting everything? The 7. That's why it was x to the 7th. This one here, what's affecting everything? The square root is affecting everything. Now in this one, the e is affecting what happens to c and x.
I thought that CX was affecting.
If we were to actually put in numbers for c and x, what would be your final step? Would you be doing the c times the x, or would you doing e to that? The e to that's the main function. Yes, e is a number. All right, the derivative of c to the x, or sorry, cx, just c.
Oh, yeah.
The derivative of x is 1. Now, what's the derivative of e to the x? It's one of those ones that were on that list a couple sections ago. It's the same thing. It's e to the x. The derivative of e to the x is e to the x. So when I'm finding k prime, I take this e to the, but instead of writing x, I put cx times by c, which is c e to the cx. You've noticed that it was pretty much the same thing, but that c got brought down. If you're taking the derivative of a to the x, anything to the x, you have the ln of a times a to the x. If you have the derivative of e to any function, you take the derivative of the function times by the original problem.
Well, these LNs and E's like perfect against each other. That was the problem.
Is it LN or logarithm?
Yes, ln, you remember, is the natural logarithm at e.
What do you mean times?
All right, we have y equals sine to the 8th power. We're going to find the derivative.
You do X times sine
The main function, what's happening? This really means sine of x to the 8th. So the main function that's overriding everything is the x to the 8th. The f is going to be the sine. The derivative of sine, cosine, the derivative of x to the 8th, 8x to the 7th. So to find the derivative of y, 8 times the original function, so sine of x to the 7th, times by cosine of x.
Oh my God, I'm right.
You have g of f times by f prime. All right, the one last part I have to really talk about, it's parametric function. Taking the derivative of a parametric. If you remember back from Algebra 2, parametrics where you have x, y's, and t's. You have an x equals something with t's, y equals something with t's. If you're trying to find dy dx, the derivative in respect to t, for parametric functions, to find dy dx, you take dy dt divided by dx dt. All right, we're going to find dy dx. What you do is you find the derivative in respect of t. So what's the derivative here? 2t. What's the derivative over here in respect to x, or in respect to t? 2. 2 divided by 2, my answer is just t. When t is equal to 6, your answer is, bam. All right, the chain rule. The chain rule, it's not always just an F and a G. Sometimes you have a 3-link chain. If you were to have a 3-link chain, you have the chain rule inside of another chain rule.